In this quiz review, we're going to, first off, retest on some of the problematic topics from Chapter 1. Our first repeat topic is going to be marginal cost, marginal revenue, marginal profit. So you have to know that whenever I say marginal always will mean take the first derivative of whatever it is. So if you're given revenue and you want marginal revenue, you must take the first derivative. So here's an example. Given cost can be determined by C of x equals 75 plus 15x plus 5x squared. Find the marginal cost of producing 4 units. So your first job is to find C prime. C prime will be 15 plus 10x. Then to answer the question, you're going to find C prime of 4, which will be 15 plus 4 times 10 is 40. So C prime of 4 will equal 50, 4 and 1 is 5, 55. Okay? So, and it would be dollars per unit. Alright, so that's all there is to it. So marginal, just remember forever and ever that just means take the first derivative. Okay, next thing. Average rate of change versus rate of change. So I've written down here that the average rate of change is the slope of the secant line. So, and therefore you do not get the average rate of change by taking the first derivative. Rate of change and instantaneous rate of change. So let's change my color and I'll underline those for you. So, rate of change or instantaneous rate of change, they are first derivatives. Average rate of change, go back to red, average rate of change, do not take the first derivative. Do not. Okay, you only take it if I ask you for plain old rate of change or instantaneous rate of change. Okay, let's go down and we'll do one of those problems next. Okay, so our example of average rate of change, the second you see the word average, do not take a derivative. So if I want the average rate of change, they have to give me an interval. Here's your interval. So the x is going from 3 to 1. So you would evaluate the function, not the derivative of the function, but just the function at 3 and subtract away r of 1 over 3 minus 1. So if we do that, r of 3, so I believe r of 3 is 28, so it would be 28 minus r of 1, 3 plus 2 minus 5 is going to be 0, all over 3 minus 1, which is 2. So the average rate of change will be 2 divided into 28, which will be $14 per unit. That is average rate of change. Okay, then they go on and say, given the revenue can be this, still same revenue, find the rate of change. If they say rate of change, I want you to think r prime. So, do take the derivative. So r prime equals 6x plus 2. Then you have to evaluate that derivative where x is 3. So that's going to be 6 times 3 is 18 plus 2 is $20 per unit. Okay? Okay, example 2c. Given revenue can be determined by this. Find the instantaneous. Okay, instantaneous is also r prime. The only thing that's not r prime is average rate of change. Okay, so I would do the exact same thing here. Get the first derivative. It's the exact same question. I would expect the exact same answer, which I get. Okay, so forever and ever and ever, keep average rate of change and rate of change separate in your mind. Okay, let's go on to the next page. Okay, our next point of confusion for some of you was the position function discussion. So position function would be your first function. So for example, that could be your h of t. Your velocity would be h prime of t, and your acceleration would be h prime prime. You need to keep those straight. Okay? So position, as I said, original function, velocity first derivative of the original function, acceleration second derivative, all typed out for you here. I will also tell you that your best bet of understanding these types of position functions is to first give yourself a sketch. So this is my h of t. So here's my time, here's my height. So once I see that, I understand that any question about the height of the function is going to go back to this position function. Any question about the velocity is the first derivative. So right here, the velocity is 0. Right here, the velocity is negative. Right here, the velocity is positive. So anything pertaining to velocity means that you have to take the second derivative. Anything pertaining to acceleration, that's going to involve the second derivative. So first derivative is velocity, second derivative is acceleration. So then, step 5 is important. If they ask at what velocity does a rocket hit the ground, you must first find the time at which the rocket has a height of 0. So that means you've got to find this time right here of the original position function. So we're going to call that TG, time hitting the ground. So then to find the velocity of that time, you would take the first derivative of the position function, which is going to be velocity, and evaluate it at time ground. So get yourself unconfused about that, because I'm going to ask you questions about that again. Okay, our last old topic is the chain rule. Now I've written out all the work for you so that you can understand it. The chain rule happens when you're not dealing with trig functions, when you have a function. So here's a function right here, and that function is raised to a power. So you have to take the derivative using the power rule, and that's happening right here. Then take the derivative of what's inside. So doing that, this derivative will be 7. 7 times the 3 will get you a 21. Don't forget to write the power, because many people go on to taking the inside derivative and they forget to put the power back up where it belongs. So here's an example without any trig. Then we have the trig function. So when we do our trig function, we do the following. We take note of whether I have a power or not of my trig function. There is no power in example 4b. Then I look over here at my angle. If my angle is not just a plain old x, I have to do the chain rule. So look, take the derivative of tan 13x and you get secant squared 13x. But you are not done. Here is the chain rule. The derivative of 13x is 13. Bring that 13 up in front, and now you are done. If you have no power, you should have just one trig function in your answer. Then we come to example 4c. I have a power right there. Okay, there's a power. So when I have a power and I have an angle that's not just plain old 3x, I am anticipating two trig functions and the derivative of my angle in there. So for the most part, this was actually handled very well, but I thought we'd just reinforce it one more time. So here is my power rule. It might help you to raise this to the first power, then take the derivative of what was inside the parentheses, and then take the derivative of the angle. Pull it all together, and here is your final answer. Okay, so that's all of the old stuff. Now I have one page of new stuff. That's just 2-1 and 2-2. Okay, for this quiz, remember how we started off just analyzing our functions. So here is how we analyzed them. Remember I said that the first three, so A and B and C, were really the new material that we use calculus to analyze things. You should still know how to do this part, but this is truly Algebra 2 and pre-calc. So be able to talk about the intervals correctly, be able to talk about the function increasing and decreasing and the slope being positive or negative, be able to discuss concavity and inflection point. Okay, so that's the 2-1 material. In 2-2, be able to give me a sketch if I give you some characteristics. So if I give you some points and I tell you about the slope or about the second derivative, which is the concavity, you should be able to get me a sketch. So look at your notes, be able to do that. If I give you a picture of f of x, f prime of x, and f prime prime of x, all on one graph, you should be able to tell me which is which. Okay, so that's kind of an important thing. You should be able to tell me about each one and also tell me which is which if I do not label them for you. So that is another important thing to be able to do. If you can do all this, you're good to go. It just takes a little practice and you will be all set.